Hello viewers, in today's class we are going to discuss one important definite integral involving the absolute value function and the concept of periodic function, right? So here we have to evaluate this integral which goes from 100 to 100 minus 3 pi, and the integrand is mod of cos x, right? So here what we will do, will use some properties of definite integrals and the concept of periodic functions, that is the period of mod of cos x, right? So here let us call this integral as I, right? So here the lower limit is 100 and the upper limit is 100 minus 3 pi, and the integrand is mod of cos x, right? Now see, we know that the period of cosine x is 2 pi, right? Because trigonometric functions are periodic, and the period of cos x is 2 pi, right? And the period of mod of cos x is simply pi, right? So here I will use this result, right? Okay, so now we have seen that the period of mod of cos x is pi, and now we'll use one important property of definite integrals involving periodic functions, right? So here we have seen that this function is periodic, right? Now let us consider the integral that is say p to p plus n times t, right? And here the function is say f of x, right? So now if we have an integral in which the lower limit is p and the upper limit is p plus n times t, and here the integrand is f of x, right? Now here f of x is periodic, right? And the period of f of x is this capital T, right? So T is the period of f of x, and p is some real number, right? So whenever we have this type of integral, that is from p to p plus nt f of x dx, then the this integral can be written as n times the integral from 0 to t f of x dx, right? So here this property shall be used to evaluate this integral. So now let us rewrite this integral as 100 to 100 plus minus 3 pi, right? And here we have mod of cos x and dx, right? So now if we compare this integral with this one, then f of x is mod of cos x, which is a periodic function with period pi, that is t is pi, right? T is pi and n is minus 3, right? So here this n is some integer, right? And the value of p is 100, right? Which is a real number, right? So now if we apply this property to this integral, then this integral can be rewritten as n times, that is n is minus 3, so we have minus 3 times 0 to t. So t is pi because the period of mod of cos x is pi, and here we have the function f of x, that is mod of cos of x, right? So now this integral is simplified to this one by using this property. So now our aim is to find the value of this integral, right? So what we will do, here we have the limits from 0 to pi. So now we'll use the concept of sign convention of trigonometric functions in the four quadrants, right? This is the first quadrant, this is second, this is third, this is fourth, and here we have 0, this is pi by 2, this is pi, this is 3 pi by 2, and here we have 2 pi, right? So we have to go from 0 to pi. right? So now what we will do, will break this limit, that is, we'll write this integral as a sum of two integrals, that is from 0 to pi by 2 mod of cos x dx plus pi by 2 to pi, and here we have mod of cos x and dx, right? Okay, so now see, in the first quadrant, that is from 0 to pi by 2, the cosine function is positive, right? And in the second quadrant, the cosine function is negative, right? So from the definition of mod function or the absolute value function, this mod of cos x is equal to positive cos x when x it lies in the first quadrant, right? That is, x belongs to the interval 0 to pi by 2, right? So in the first quadrant, cosine function is positive, and in the second quadrant, we have cosine of x is equal to mod of cosine of x is equal to negative of cosine of x, because x lies in the interval pi by 2 to pi, right? So this is the second quadrant, this is the first quadrant, right? So now here mod of cos x is replaced by positive cos x, and here mod of cos x is replaced by a negative cos x, right? So now we have minus 3 here, and we have 0 to pi by 2, and now we have here plus cos x dx, and here we have negative of pi by 2 to pi and cos of x, right? Okay, so now we have two simple integrals, and we know that the integral of cosine function is sine x, so that is sine x, and limits are from 0 to pi by 2, and here we have minus, and integral of cos x is sine x, and the limits are from pi by 2 to pi, right? So now we can simplify this expression by substituting the limits and taking the difference. So we have minus 3, and here we have sine pi by 2 minus sine of 0, and here we have minus, and sine of pi minus sine of pi by 2, right? Okay, now we can write minus 3, and here we have sine pi by 2 is 1, and sine 0 is 0, so we have here minus 0. Here we have sine pi, that is 0, and sine pi by 2 is 1, right? So this is minus 3, and here we have 1, and here minus and minus becomes plus, so we have 1 plus 1, right? So this is minus 3 times 2, that is minus 6, right? So the value of this integral is equal to minus 6.